across the endless dark of interstellar space, where stars drift like embers suspended in an eternal night, something ancient and silent was moving. It had wandered for eons beyond the faintest reach of sunlight, tracing an orbit no star could claim, carrying within its frozen heart the memory of a system long extinguished. Then, in the spring of 2020, as Earth's telescopes swept the heavens, our species caught a fleeting glimpse of it, a new messenger from the void, a visitor known as 3I ATLA. Yes, to the untrained eye, it was just a smudge of light, a faint wisp against the dark tapestry of the cosmos. But for astronomers, it was a revelation, a living fossil from another star, gliding into our neighborhood like a page torn from an alien history book. 3I Atlas wasn't our first interstellar visitor. 2 years earlier, the enigmatic Oumuamua had startled the world with its strange shape and mysterious acceleration, raising questions that hovered between science and imagination. But Oumuamua was frustratingly evasive, a ghost that came and went before our instruments could truly study it. 31 ATLAS, by contrast, offered a second chance, a clearer window into the unknown. As it approached the sun, it began to behave more like a comet, developing a diffuse coma and a faint tail of gas and dust. Yet even this resemblance carried an alien twist. For the first time, humanity would witness, through spectroscopy, the chemical fingerprints of a world not born under our sun's light, but under another. The heart of any comet is a paradox. It's both fragile and eternal, a frozen relic that endures the birth and death of stars, preserving molecules older than planets. When sunlight strikes its surface, those ancient ices awaken, vaporizing and releasing clues to their origin. And in 3I ATLAS, scientists detected something that defied all expectations. Nickel? Not just traces or hints, but clear spectral evidence of gaseous nickel atoms sublimating directly into space. Now, nickel is a heavy element forged in the fiery crucibles of supernova. It's not the kind of substance that typically evaporates easily. On ordinary comets from our own solar system, nickel tends to stay locked inside dust grains, requiring extreme heat to escape. Yet here was a wanderer from another star, displaying a phenomenon that seemed to rewrite our understanding of cosmic chemistry. Why was nickel, an element of such tenacious solidity, drifting from its frozen nucleus in the cold vacuum near the sun? The detection came from the exquisite precision of high-resolution spectroscopy light split into its component colors, each wavelength carrying the imprint of a specific element. Observers using the Very Large Telescope in Chile found unmistakable signatures, narrow emission lines corresponding to neutral nickel atoms glowing faintly in the comet's coma. It was a revelation as delicate as it was profound. For a moment, a bridge of light spanned the gulf between two star systems. Through that faint shimmer, we were reading the story of another sun's creation, its metals scattered and recycled into this interstellar vagabond. To appreciate the magnitude of this discovery, we have to go back to the origins of heavy elements. In the hearts of massive stars, nuclear fusion forges ever heavier nuclei until it reaches iron and nickel, the point where fusion no longer yields energy. When such stars die, they explode as supernova, scattering nickel, iron, and other metals across the galaxy. These elements seed the formation of future worlds, becoming part of planets, meteorites, and even life itself. So, to detect nickel in an interstellar comet is to glimpse the ashes of a long-dead star, a remnant of stellar evolution from another corner of the Milky Way. It's as if 3I Atlas carried the breath of its parent sun, whispering across the light years about the cycle of birth and death that unites all matter. The realization that both 3I Atlas and even some comets from our own solar system can release nickel vapor in cold conditions challenges old assumptions. Traditionally, scientists believed only near-sun encounters, at temperatures over 700 degrees Celsius, could liberate such metals. Yet both interstellar and local comets showed these emissions even when they were hundreds of millions of kilometers away from the sun, where the temperature barely rises above -100 degrees Celsius. This implies that nickel might not always be buried deep in metallic grains. It could be bound within more volatile compounds that release atoms through subtle photochemical processes. In the quiet spectrum of a distant comet, the cosmos revealed a chemistry more intricate and nuanced than we had dared to imagine. For planetary scientists, 3I Atlas became a living experiment. Each data point was a rare test of how planetary systems form under different conditions. Was this comet born in the outer regions of its parent star's protoplanetary disk, far from heat and light? Or was it flung into interstellar exile by gravitational encounters with giant planets? The answers are still incomplete, but their implications are vast. 3.1 TLAS reminds us that planetary systems, though separated by unimaginable distances, are built from the same universal ingredients. The detection of nickel suggests that heavy metals might be more evenly distributed across cosmic environments than we once thought. It tells us that the processes shaping comets in our solar system are not unique to our Sun, but common to the galaxy itself. In a deeper sense, the discovery is philosophical. It invites us to reflect on our place within a universe that is both ancient and continuous. Every atom in our bodies, every element in our world has shared the same cosmic journey as 3I Atlas. The nickel in that comet's coma is kin to the nickel in the core of our Earth, and even to the trace metals coursing through our blood. The comet's arrival was not just a scientific event. It was a homecoming of matter, a reunion of elements long separated by the slow drift of time. When astronomers calculated its orbit, they found it to be hyperbolic. Its speed and trajectory ensured it would never return. Once it passed through our solar system, it would sail again into interstellar darkness, perhaps to wander for another million years before brushing past another sun. For all our instruments and intellect, we could observe it only briefly, like catching the glimmer of a ship crossing the horizon. And yet, in that moment, we learned something timeless, that even in the most transient encounters, the universe speaks to us in an elemental language. The study of 3I Atlas has also rekindled our curiosity about interstellar visitors. If two such objects have crossed our path in just a few years, then the galaxy must be teeming with them. Each one carries a different story, a distinct chemical signature, and perhaps even clues to the formation of life itself. Future observatories like the Vera C. Rubin Observatory will scan the skies with unprecedented sensitivity, capable of detecting many more of these interstellar travelers. With each discovery, we will refine our understanding of how materials migrate between stars, connecting planetary systems through invisible threads of dust and ice. The detection of nickel was more than a chemical curiosity. It was a message about persistence. Here was an element that had endured the explosion of a star, the formation of a new system, the ejection from that system, and the vast cold exile between the stars only to reveal itself again when touched by the light of our sun. It speaks of the durability of matter, the indifference of time, and the continuity of the cosmic cycle. As 3I Atlas receded into the outer darkness, telescopes followed it until it vanished. What remains is not the faint trail of its passing, but the knowledge it left behind. Through spectroscopy, we caught a glimpse of its composition. Through imagination, we caught a glimpse of ourselves, creatures of stardust trying to comprehend our origins. The comet's nickel lines, faint as whispers, remind us that even in the smallest details of physics lies a vast poetry. They tell us that the laws governing atoms are the same across every corner of the cosmos. In the quiet after its departure, scientists continue to model and theorize. Perhaps one day, a spacecraft will intercept an interstellar object directly, tasting its gases and touching its ices, bringing back samples that will answer questions still beyond our reach. Until then, 3I Atlas remains both mystery and a symbol of the dialogue between humanity and the universe. It reminds us that discovery is not an act of possession, but of connection. We didn't capture the comet. We shared a moment with it, and in that moment we awakened to a deeper understanding of what it means to belong to the cosmos. The tale of 3I Atlas and its surprising nickel is a reflection on existence itself. It teaches us humility, the awareness that our sun is one among billions and our matter is shared with the stars. Yet it also grants us wonder, the realization that we are capable of noticing, measuring, and feeling awe at the faintest glimmer from across interstellar space. The universe is vast, but through science we have found a way to listen to its heartbeat. So, as our telescopes gaze once more into the blackness, searching for the next visitor, we do so with renewed reverence. Somewhere out there, another wanderer drifts silently through the dark, carrying the ashes of suns we have never seen. One day it, too, may cross our sky, awaken beneath our sun, and reveal another secret in the spectrum of its light. Until that day, we remember 3I-ATLA as a messenger from beyond, a traveler between worlds, and a mirror held up to our own cosmic heritage. Thank you so much for joining me on this cosmic journey. If you found this story as awe-inspiring as I did, please consider liking this video and subscribing to our channel for more explorations into the mysteries of the universe. See you next time.